Hey guys, welcome to another video of statistics, and the objective of this video is to introduce the definition of sample mean and sample variance. And then afterwards, the objective of the next video will be looking at the stem and leaf display. So let's start with the introduction of the sample mean. So firstly, the sample mean is defined as the simple average of the n observations. Okay, so for example, let's say we start off with a set of data. And we're given n numbers, and we denote them as x1, x2, x3, all the way to xn. Okay, so we're given n amount of numbers, and we call this our sample size. So the sample mean is basically the average. So we denote that as x bar, and that's equal to 1 on n times the sum of x1 plus x2 all the way to xn. Or in other words, we can let that equal to 1 on n times sigma I equals to 1 n xi. So this sigma here is called the sigma notation. Okay, so what that means is that we're taking a sum of all of our xi's starting from x1 to xn. Okay, so you can think of this notation here as equal to this here. Okay, so that's what this sigma notation means. Okay, but basically it's equal to this. Okay, so let's now introduce the definition of sample variance. Okay, so a sample variance is basically the average of the squared deviation from the sample mean. So again, let's start off with a set of data. So we're given x1, x2 all the way to xn, and n being our sample size. So before we calculated our sample mean to be x bar. So what I mean by square deviation is, so basically a deviation is looking at how far each number in our data are away from our sample mean. So that's basically xi minus x bar. The squared deviation is a square of that. So it's squared, okay, of how far each number in our data is of x bar. Okay. So that's what a squared deviation is, okay? The square of how far each number is from our sample mean. So the sample variance, again, is defined as the average of the squared deviation, okay? So again, we take an average. So our sample variance, we're going to define this as sx squared. And so that's equal to 1 on n minus 1 times sigma I equals to 1 n of xi minus x bar squared, okay? So basically summing up all of our square deviations, okay, and dividing that by the amount of deviations that we have, which is what the average is. And so some of you may ask, why not take 1 on n, and instead we have here 1 on n minus 1. Well, in statistics, we define the sample variance with 1 over n minus 1 instead of 1 on n. And that's the convention that we use as a definition for sample variance, okay? So we use 1 on n minus 1 instead of 1 on n. So here, if we expand this summation here, we'll get something like this. Okay, so we get something like this, where we have 1 on n minus 1 times the summation of xi squared minus the summation xi entirely squared over n. So by summation of xi squared, I mean x1 squared plus x2 squared all the way to xn squared. Okay, so you must make a summation of this. Okay, and by summation the entire thing squared, I mean this here, basically where we firstly sum up all the numbers x1 plus x2 all the way to xn, and then we're going to square them. Okay, so once you find these two numbers, okay, these two summations, you sub them into the equation, okay, and we know what n is because that's our sample size. You can then find our variance, the sx squared. So this leads us to another definition, okay, which is called the sample's standard deviation. So that's defined as the non-negative square root of the sample variance. Okay, so a non-negative square root of the sample variance. So SD, which is our sample standard deviation, that's equal to Sx, which is equal to the positive or the non-negative part of the square root of the sample variance, Sx squared. So we're going to sub in what we had from before, Sx squared. So we said that was equal to 1 on n of times summation of xi minus x bar squared, Okay, so so the square root of that will just give us our XSD. Okay, so that is, again, from before we said that that the sx squared was equal to 1 on n times the summation of the square of numbers minus the square of the sum of numbers over n. Okay, so we sub that in, and that will give us the square root of this. Okay, so basically you sub in all numbers and then take a square root, and that will give us our SD. Or you could just find our sample variance first. Okay, so find our sample variance sx squared. Okay, sub in all numbers and then take a square root. Okay, take a positive square root of that, and that will give us our SD. Okay, so this is the formula for the sample standard deviation of our data. Okay, alright guys, see you in the next video.